Okay, we're going to look at our 2015 Core Maths Practice Exam Solutions, and only just for the multiple choice section in this video. So let's get started. So question 1, the following frequency distribution table shows how far a group of students could run in 60 seconds. Okay, so we've got distances, and the distances are grouped from 40 to 49 and 50 to 59, so they're grouped in tens. And then the frequency here is counting how many data amounts fit in those groups. And the question is, the modal class is. Now, modal class refers to the mode number. Now, the mode number means the most common or most likely. Alright, so but in terms of the modal class, we're referring to a group of data, such as these ones. Okay, so by thinking the frequency as the amount in each group, the amount of data in each group, the group that has the most amount of data, or the most common amount of data, is 18. So question D, option D is correct. Let's go to the next part. So I'm going across ways over to question 5 here. Now the area of the trapezium shown below, so looking at this trapezium, the area of the trapezium is given by this rule: half times A plus B times H. Now we need to know on our trapezium, what does each of those letters refer to? So on your formula sheet you should have a picture of a trapezium with the rule for its area, and the top length you can call length A, the base length you can call length B, and then the perpendicular length to the base is the height, and you can call H. So take those numbers and put them in the right spot in the rule, and on the calculator we add the 8 plus the 10 to give 18, and then we carry out the multiplication to get 36, and we have E. Alright, the next question, the surface area of a sphere with diameter 20 centimeters is closest to. So I need to know a rule for the surface area of a sphere. So I look up my formula sheet, and on it I'll have a picture of a sphere with the rule for surface area 4 pi r squared. So it's 4 times the pi times the radius squared. Now the radius is worked out from the information about diameter. Diameter is always twice the radius, so if diameter is 20, the radius must be 10. So I'll have 10 squared there in that part of the calculation. And in the calculator, that will give me 1256.6, which is closest to D as your answer. Everyone following on? Let's look at the next part. Alright, so here we have a set of data, and this data refers to both question 2 and question 3, this one and this one. Okay, so the first part, question 2, the mean of the data is closest to. Now the mean is an average, and we work it out by adding up all the values. So add them up to get a total, and then we have to remember to divide by how many we have. So we've got 7 data points, so we're dividing by 7 at the end. So our total 233 divided 7 gives us a 33.3, closest to D. Now the range of the data here is the maximum value subtract the minimum value. That's how you work out your range. So you look up your maximum value, which is 37, and you subtract your minimum value, which is 30, and we get a range of 7. Okay, it's not too hard. Now, question 4, the IQR of the following box plot is. Now, who remembers what IQR stands for? It is the interquartile range. That's right. Now, your interquartile range is, think of it as the size of the box, only that part. And it's worked out by taking the third quarter and you subtract the first quartile. This part of the box plot, that's Q3, that's your third quartile. That part of the box plot is your first quartile. And we look from the graph, so Q3 is approximately here, which is about 23, and Q1 from here is about 15. 23 subtract 15 gives us 8, and there it is, option B. Okay. Alright, question 7. Here we have a measurement problem. We've got a shaded region determined by two circles, a smaller circle and a larger circle. So the shaded area in the above diagram, we can work out that total area by working out the area of one shape, and we subtract the area of the other shape. In this case, we're going to work out the area of the large circle, and we're going to subtract the area of the small circle. Area of a circle is pi times the radius squared. So the radius of the large one is 7. And we're going to subtract pi times the radius squared of the small circle. And the radius of the small circle is 3. Put that in the calculator, and we get option C, 125.7. Okay? Okay, question 8. Here we have a cylinder. The surface area of the cylinder is. So, surface area of a cylinder. I need to look up my formula sheet that I have in my summary notes, and I'm going to find a cylinder and write down the rule for the total surface area of a cylinder, 2 pi r squared plus 2 pi r times the height. That's the r, that's your radius of your cylinder. And this number here, that is the height of your cylinder. So we use those values and we put it into the rule, use our calculator, and we'll get 8.2. That's number C. Okay? Next part. So, the strength and direction of the scatter plot below. Now, as you can see, this is a scatter plot. Doesn't seem like a perfect straight line, but it does look fairly like a straight line. And it kind of going down. So any downward trend, we say it's got a negative direction. Okay. Now, if I put a straight line through that, I'd say each of those points will be pretty close to the line. So, because they're almost straight line, they form almost a perfectly straight line, we say we've got a strong correlation. Okay? So, that is option A. Question 11, find the equation that represents the line below. Alright, so on a Cartesian plane, x and y, we've got a straight line, and here's our points. This point there, which is the y-axis intercept, is x equals 0, y equals 4. This point down here on the x-axis intercept is x equals 6, y equals 0. So my equation of a straight line is this, y equals mx plus c. I can work out my c number straight away because my c number is just the same as the y-intercept. You have to remember that. The y-intercept, which is that point, is your c number, c equals 4. Okay, now I've got that part of my equation. Now I have to work out my m. Now my m is the gradient, and the gradient is rise over run. Now, as you can see, I've crossed off a couple of options here. Why? Well, option B and option C and option D, they don't have a y-intercept of positive 4. So that makes it easy. Once I work out just one part of it, like the y-intercept, I can come over and check and to see which ones don't fit with a y-intercept of 4, and I can cancel those ones out. So really I've just got option A and option D. It's like a 50% chance. So even if I don't know, I can flip a coin and pick one, and I might be pretty close to being correct. But if I do want to work out the gradient, I will need my rise. So I can draw a little right angle triangle here, and I can measure a rise of 4, and I can measure a run of 6. So the gradient is rise divide run, 4 over 6, which is the same as 2/3, 2 over 3. Now, have a look at the trend. It's going down, so it's a negative. Downward trend, so it means it's a negative. And how does that affect the gradient or the equation? Well, the negative sign would appear right there in front of the gradient number. Alright? So if you've got a negative trend, that means the gradient is going to be a negative number. It's a very important thing to remember there. So altogether, there's my equation with my m number, and that is option D. Okay. We're almost there. Question 10, we've got the area of an ellipse. And that's what we have to work out. So I go to my formula sheet and I look up the area of an ellipse, which is pi times the a number times the b number. And I make sure I label them. Up one could be the a number, and the one that's going across can be the b number. So in my calculator, I'm going pi times 2 times 5, which gives me 31.4, which is closest to D. Okay? Now, question 12, the strength and direction of the scatter plot below. Well, here's your scatter plot, and you can see this time they're fairly in a straight line direction, but they're going upward trend, so we've got a positive direction. But when you look at the points, they're fairly scattered around the line. So it's not a really strong correlation in this case. So when the data is scattered around the line, we say it's a weak correlation, a weak strength. So that is B. Question 13, calculate the gradient of these 2 points. We've got 2 points on the line. Now, to work out the gradient from 2 points, 2 coordinates, I first label each coordinate. This is an x1, y1. And the second point, I'm going to label x2, y2. Always x first and then y is second. Now the gradient, the rule for gradient is worked out by finding the rise, which is the same as y2 subtract y1. And divide the run, which is x2 minus x1. And then I plug in my numbers into each position in the rule, and I evaluate, and here I will get -1 as my answer. Alright, and last 2 questions. Question 14, rearrange the following equation to solve for C. So this is like determining the y-intercept, the C value of a straight line, y equals mx plus c. So when I look at the equation, this is a 3 outside a bracket with a 4 in it. So that's a 3 multiplied by a 4, which gives me a 12. And then I can rearrange it by subtracting 12 to both sides to bring my numbers together, the units together, and get the c by itself, the negative c. So this says 6 is the same as negative c. So what would positive c be the same as? Negative 6. The signs just swapped there. And that's B. And finally, question 15, find the median value, the middle number of our data set here. Now, before I do that, I have to make sure that the data set is rearranged in order from smallest to largest. So I rewrite the data set, and as I write one down, I'm going to cross off my original list so I don't lose track of anything and I don't double up. Okay, so there's my data set rearranged. Now the middle is right there, and one way to check that I've got the middle is to count the amount of data to the left and to the right of the line. So that's 1, 2, 3, 4 to the left, and 1, 2, 3, 4 to the right, and that's definitely the middle. But there's no number there, so you have to ask yourself, well, what's the middle number in between a 7 and a 9? And one way you can work that out is by adding the 2 numbers, 7 and 9, to give 16, and then you halve it. You just simply halve it, divide by 2 to give you 8. And there's your median number, option C, and we did it. So we've finished the multiple choice selection section, and I'd like you to revise that carefully again and prepare some notes on your summary sheet that you're going to take with you into the exam. And next video we're going to be looking at our short answer questions. Well done, everybody.